Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Today's lesson is on Newton's second law of motion. Newton's second law of motion helps us understand how force and mass are related to acceleration. Before we can understand that relationship, it is important for us to understand what balanced and unbalanced forces are. Let's look at balanced and unbalanced forces. If two groups of students are playing tug of war, the rope isn't moving. Are they using equal or balanced forces? Yes. You can see that the rope isn't moving, and with no movement, the forces are equal. Each group of children, they're not even budging. They are exhibiting balanced forces. This is important to remember. Balanced forces are two opposing objects pushing or pulling each other and have a net force of 0 or no movement. By the way, the size and direction of the arrow indicates how big the force is and in what direction the force is going. If one side of the tug of war, of the group of students, were to be moving in that direction, the forces are now unbalanced because there is movement. So what you're seeing is a representation of the forces by the size of the arrow. If the arrow is larger, the force is larger. What happens if you push your book off your desk? What forces are involved? Are they equal or are they unequal? There's movement, so the forces are unequal or unbalanced. Remember this, unbalanced forces are two forces which can be in the same direction or opposite direction, but the net force does not equal 0. There is movement in the direction of the greater force. This is an example of two opposite forces, one greater than the other. The net force moves in the direction of the greater force. It doesn't matter in which direction the forces are going. If there is movement, the forces are unbalanced. But what happens when an unbalanced force acts on an object? The second law tells us that this type of force will change the velocity of an object by changing either its speed or its direction or both. Such changes in velocity are called acceleration. So we can say that any unbalanced force acting on an object produces acceleration. That brings us to the one totally important formula when it comes to forces. F equals ma. And the formula will be on the test. F is equal to force, m is equal to mass, and a is equal to acceleration. F is the total or net force, the sum of the forces acting on the object. You also can read the formula as the following. The net force applied to the object equals the mass of the object multiplied by the amount of its acceleration. But the easiest way to learn that and to memorize that is F equals ma. So, okay, what does this mean to you? You have a formula, you have a definition, now where do you go from there? You can calculate the net force of an object. And why might you want to know that? If you want to change the object, you want to apply an unbalanced force to it in order to change it. Remember, if you want to move it, you need an unbalanced force. You need to apply a greater force than what was already being exhibited. So we have a soccer ball. It sits on the ground. It's not moving. Obviously, if you're in the game, you want it to move. The wind is not moving it. Why? Because the wind's force is not greater than the soccer ball. The weight of the soccer ball's force pulling it down is greater than the wind. However, you want to score that goal. So what happens? You apply a force to that soccer ball. You kick it. Your force of kicking the soccer ball is greater than the force of the soccer ball sitting on the ground. And hopefully, with that unbalanced force you just applied, you're getting it in the goal. The net force acting on the soccer ball is equal to the mass of the soccer ball multiplied by its change in velocity each second, or its acceleration. Okay, do you remember what I just mentioned? The wind gently blowing on the soccer ball? The force acting on the ball was very small because the mass of air was very small. Small masses generally exert small forces, which generally result in small accelerations or small changes in motion. The greater the mass, the greater the change, the greater the acceleration. You have an unbalanced force, and therefore you expect your force to move the soccer ball. That would be your foot kicking the soccer ball. The second law shows that if you exert the same force on two objects of different masses, you will get different accelerations or changes in motion. The effect or acceleration on the smaller mass will be greater or more noticeable. For example, the effect of a 10 Newton force on a baseball would be much greater than the same force acting on the truck. The difference in effect of acceleration is entirely due to the difference in their masses. The second law goes on to show mathematically the exact relationship between force and acceleration. The acceleration of an object is directly proportional to the sum of all forces acting on it, that would be net force, and is inversely proportional to its mass. Mass is simply the measure of the quantity of matter that makes up the object. The important thing to remember is the more mass an object has, the more difficult it is to change its state of motion, whether it is at rest or moving in a straight line at a constant speed. Can you move a soccer ball? Yes. Can you move a car? No. Why? One has greater mass than the other. Think of it this way. An elephant has more mass than a mouse. It is much harder to push an elephant across a floor than it is a mouse. And it's much harder to stop that elephant once it's moving. We can also say that the elephant has much more inertia than does a mouse. Inertia and mass are just different ways of expressing the same concept. Okay, as a mathematic formula, remember I mentioned F equals ma, or force equals mass times acceleration. Now it's very important for you to remember this. The unit of force is the Newton from Sir Isaac Newton, which is equal to N equals kilogram times mass per second squared, where N stands for Newton. Kilogram is the mass for the unit for mass, and meters per second square is the unit for acceleration. Let's look at an example. Remember, force is a push or a pull. Take the tape dispenser. Use a force, which is your finger, and push it across the table. Now let's look at the math behind this. Suppose the tape dispenser has a mass of 0.5 kilograms. The dispenser is accelerating at 4 meters per second squared. So A equals 4 meters per second squared and M equals 0.5 kilograms. Calculate the force. F equals 0.5 kilograms times 4 meters per second square. So F equals, do the math, 2 kilogram meters per second square, or 2 newtons. What happens if we know the force and the mass and we need to find the acceleration? We can divide both sides by m, so let's take a look at that. F equals ma. Change that formula to ma equals F. Divide m on both sides. ma over m equals F over m. Cross out the math on the left and you get A equals F over m. By the same token, you know the force and the acceleration, you can find the mass. Divide both sides by acceleration, the same as you did with the mass. So you have F equals ma, switch it to ma equals F, then divide both sides by A, ma over A equals F divided by A, cross out the A, and you're left with m equals F divided by A. Let's try some practice problems on force, motion, and acceleration. Okay, so let's take a look at these problems. Take a look at the first problem we have. We have a net force of 10, so that means F equals 10. We have a mass of 2 kilograms, so M equals 2 kilograms. We're missing acceleration. What is the formula for acceleration when we already know force and mass? It is A equals m over F. So let's put that together. We have mass, which is 2 kilograms, and we're going to divide by 10 newtons. 2 divided by 10 is half, or 0.5. And what are the units? Meters per second squared. For number 2, now we have double the force, which is F equals 20 newtons. Again, we have the mass, which is equal to the same amount, 2 kilograms, and we're still missing acceleration. So we have A equals mass over force. So 2 divided by 20 is 0.1 meters per second squared. Let's take a look at 3. Oh, same force. Force equals 20 newtons. But now this time our mass has doubled. M equals 4 kilograms. Again, we're still missing acceleration. So A equals m divided by F, or 4 kilograms divided by 20 newtons equals 0.2 meters per second squared. When we come to number 4, now we're missing the force. So F equals ma, we're looking for force. We know m, which is 2 kilograms, and we know acceleration, which is 5 meters per second squared. And we do straight multiplication there. 2 times 5 is 10 kilogram meters per second squared, or 10 newtons. Our last problem, we know the force, which is 10 newtons. We don't know the mass, and we do know the acceleration, which is 10 meters per second squared. So we need to look at the formula where we're missing m. m equals F over A. Force is equal to 10 newtons divided by 10 meters per second squared. Let's see. 10 divided by 10. Oh, wait, I know that one. It's 1. So 1 kilogram is our answer. Now, that's straight arithmetic, straight math. However, in science, it gets a little more complicated than that. Let's look at our sample word problem. If a car has a mass of 70 kilograms, so that means m equals 70 kilograms, and the driver pushes the car with an acceleration, also known as stepping on the gas pedal, with an acceleration of 0.05 meters per second squared, what is the force? So really what you want to find out is, you know what the mass of the car is, you know how fast the car is accelerating, you want to know what kind of force that car has. So A equals 0.05 meters per second squared. Our formula is F equals ma, so our math is 70 times 0.05. And our answer is a force of 3.5 newtons, or kilogram meters per second squared.
Thank you for joining us on how to improve science performance through strategic note-taking.